All right, for R6, we're going to talk about derivatives involving trig functions. So we're going to use the first 6 trig functions that you are familiar with: sine, cosine, tangent, secant, cosecant, and cotangent. That is a typo, CSC. That should be a cosecant. But these are just rules. I'm not going to take the time to explain where all these rules come from. You can prove all these with the difference quotient, but that's not going to be a part of this video. I'm trying to keep things really simple, so we're just going to go with the fact that these rules work and they did come from somewhere. Nothing really new here other than these rules. We're going to apply the product rule, the power rule, the chain rule, the quotient rule throughout. We're just going to use trig functions to do that. And then with trig functions, the chain rule is really common, so just make sure you are aware of that. I'll keep these derivatives on the screen so I can refer back to them, and then we'll just go from here. So the derivative of cotangent I see is negative cosecant squared. That's my first one. I kind of jumped ahead. Sine, tangent, secant. See how none of those have a co, and they all end up as positive. Okay, and then cosine, cotangent, cosecant all end up as negative. So that's a quick way of remembering. If it starts with a co, it ends up as negative. If it starts without the co, it ends up as positive. And then you basically have 3 rules to remember. Sine becomes cosine, and cosine becomes sine. Tangent becomes secant squared. Cotangent becomes cosecant squared. So if it has the co, it still has the secant squared. It just is going to have the co in front of it. So cosecant squared. And then secant is secant tangent, secant x, tangent x. Cosecant would be negative cosecant cotangent. So again, just same basic rule. The co's have a negative and the co out in front. So that being said, the derivative of cotangent is cosecant squared. So f prime of x equals, this is a chain rule problem. I have a cotangent to deal with, and then I have an x squared to deal with. So there's a function x squared inside of the cotangent function. This would be negative cosecant squared of x squared, because I don't touch the inside, times the derivative of the inside is 2x. And that is that guy right there. So f prime of x equals negative cosecant squared x squared times 2x. Okay, next one, secant. So this f prime of x equals, this is secant tangent. That x should not be there. So secant x squared minus 3. That's what I was going for when I wrote that problem. So just reset there. F prime of x, it's going to be secant x squared minus 3 times tangent x squared minus 3. And then the derivative of x squared minus 3 is 2x. So once I take care of the secant, I have to use the chain rule to take care of the derivative on the inside. Notice how the x squared minus 3 went to both the secant and the tangent in that derivative. Okay. And then this guy, f of x equals, this is the 3-layered chain rule problem. Cosine of x cubed minus 4x quantity squared. So I take care of the square first, meaning that f prime of x equals 2 times the cosine of x cubed minus 4x to the first power. Again, you don't have to put that first power. I just do for clarity's sake. Then multiply that by the derivative of cosine is negative sine of x cubed minus 4x. And I should have used a different space on my table. But then I would multiply by 3x squared minus 4, which is the derivative of the inside. So peel your layers back one at a time. You have 3 things multiplied together. Just for clarity's sake, I'm going to rewrite that here. F prime of x equals 2 times the cosine of x cubed minus 4x times negative sine of x cubed minus 4x times 3x squared minus 4. And that should get us all in one line, but that's how you would use those different rules for those trig functions.